Differentiating terms in the form of x to the power of n. Now, when we differentiate terms in the form of x to the power of n, we can use the standard result for differentiation to do this. The standard result is here when we have a term which is in the form of ax to the power of n. When we differentiate, we multiply the power n by the a, getting an, and then we reduce the power, so the n reduces to n minus 1, giving us an x n to the power of it, and x to the power of n minus 1. So y equals this becomes dy by dx is equal to that. So let's take a look at how we can apply this standard result to these examples here. So first example here, we can say that in this case, we can say let y equals to 4x cubed plus 2x, and therefore dy by dx is going to be equal to, well, we multiply the 3 by the 4, that gets us 12x, and then we reduce the power here by 1, so that then becomes 2. Plus, we'll do the same thing to the second term. We'll differentiate that second term separately, independently of the first. So the power on the x, when there's nothing written, is 1. So 1 times 2, which is 2. And then we're left with x to the power of 0. Now we know x to the power of 0 is 1. So this tidies up to 12x squared plus 2 is the gradient function dy by dx for part A. Part B, y is equal to x cubed plus x squared minus x to the power of a half. Now when we differentiate this, we get 3x squared plus 2 times 1 here, so 2x, reduce the power from 2 to 1, minus a half times the minus 1, which gets us minus a half, x to the power of reduce the half by 1 to get us minus a half. So that's part B. And likewise, part C here, y is equal to a third x to the power of half plus 4x squared. When we differentiate this to find dy by dx, remember we multiply the coefficient in front by the power. That gives us 1 over 6 x to the power of, we reduce the half by 1, gives us minus a half, plus 2 times the 4 gives us 8, reduce the power by 1, x to the power of 1. Applying the standard results here, we're differentiating each of those terms. Y is equal to 1 over 4 root x. Now, as you can see, this is not in the standard form. It's not in the form of x to the power of something. We've got a surd here. So the first thing that we need to do is tidy up, use some indices laws. Using indices laws, first of all, we're going to change this surd into an indice. So this is the same as root x is the same as x to the power of a half. Next thing which we're going to do is we don't want the x to the power of a half to be on the denominator. We want that to be on the numerator. So we are going to use the reciprocal rule indice, where we change the power to a negative and bring the x to the power of half up to the numerator. So it becomes 1/4. That remains as it is. X now becomes the numerator and the power changes to negative. So this is still y. So we haven't differentiated it yet. All we've done is we have written this in a different form, ready to then differentiate. Now we can start differentiating. Let's write down dy by dx. Again, multiply the coefficient here by the power. So we get 1/4 times minus a half, which is minus 1/8 x to the power of minus a half. Take away 1 from it, gets us minus 3 over 2. Second one, similar thing here. We'll write down y is equal to x cubed 3x plus 1. What we can notice here is that at the moment we've got 2 factors. It's a factorized form. When we want to differentiating using the standard result, we are going to expand this and get it into separate terms. Later on in year 2, we'll look at using the product rule, which can be used in this case as well to differentiate directly. But here we're going to start by expanding, so this then becomes 3x to the power of 4 plus x cubed. Now we haven't differentiated yet, this is still y equals, okay? Now we're going to differentiate because it is in a form which is ready to be differentiated. 4 times 3, which is 12, x to the power of 3 plus 3x squared. Likewise with part C here, let's write this down. Y is equal to x minus 2 over x. So we don't want to have anything where we've got x's on the denominator, nor do we want to have surds. We want to simply get terms with x's with indices. So first thing which we're going to do is divide through by x squared. So we end up with x over x squared minus 2 over x squared. Let's tidy this up. X over x squared becomes, well, we can subtract the powers when we're dividing by x to the power of 1 divided by x to the power of 2, which becomes x to the power of minus 1. And here we will bring the x squared to the top and change the positive power to a negative power. So it becomes minus 2x to the power of minus 2. This is still y. Now we're going to differentiate and find dy by dx. So the power minus 1 multiplies the coefficient, which is 1. So this becomes minus 1 x to the power of, reduce the minus 1 by another 1, that becomes a minus 2. The power on the second term, minus 2, will multiply this to get us positive 4. And then we reduce the power by 1, so minus 2 take away 1, which gives us minus 3.